what will happen with that. We don't.
I have another question. So
Yeah.
when from the grid of the students' labs that you showed, I couldn't read it, but
Yeah.
so the students are all doing kind of different labs at different times, and then what's the there's like one instructor in the class?
Yes.
So how does that work?
So basically, what you spend most of the time just for going from station to station and helping out where it's needed.
Okay, so they're all, it's like a lab catered situation.
Yeah, there's like a couple of rooms.
Yeah, there's a bunch of different.
Okay, yeah, that's very similar to the research methods class that the CT students would be taking.
Yeah, I mean, the only problem is this is more advanced topic-wise,
You
and
have to be a senior physics major.
But what
for
do you
sure.
imagine it counting if there was?
Oh,
Since
yeah.
there is that individual catering, then there could be also a master teacher working with the student to figure out how that would look in a high school classroom. So that's kind of the intent of the question. As long as it is individually catered, one can cater it individually.
Yeah, so in terms of who takes the course, it seems like it's actually changed a lot over the last 7 years. This was as far back as we could get data from the course system. So the high number of just total students, which is the top curve, was like 40, and it had a low of I think 13 in 2009, but typically it's been around 20 or a little more than 20. But the physics number of physics majors taking the course, it used to be dominated by physics majors. And that's dropped off, and so now it's maybe a third physics majors, and it seems that engineers are taking over, and now it's at least half engineers, if not more.
well, that's engineering physics.
Engineering physics, right? So I guess one thing I'm not clear. So one of the things I want to understand is like, what is the difference between those majors? Where do they go?
The majors are nearly identical in terms of all courses taken. It's just which school you're in.
Yeah.
Except for the lab requirement. So there is an upper level engineering lab requirement, which a lot of people actually take this course to satisfy.
And it's not required for physics.
Right.
So
And this is, are those numbers per year or per semester? So it's half per semester?
Well, there's
no,
only one.
It's only a
it's one-
spring
It's only taught in the spring.
course. Yeah.
That's a really big decline in the number of
Yeah, the number of physics majors hasn't been declining, right?
No,
so
I
it's
don't
just
know.
it's just participation in
no,
this.
it's like going up.
You can either satisfy the research requirement by research with professor or this class.
No, in
you
fact, you can't.
cannot satisfy
officially.
research by this class. According to the chair of the advising.
For physics.
For physics,
I'm
yeah.
sorry, for engineering physics, that's
Yeah.
okay.
Right.
Okay. So for physics, this course doesn't satisfy any requirements.
It's just an elective,
Elective.
among a list of electives. Yeah.
Yeah. So about 4 or 5 students think it's fun to take every year. But back when they really believed they needed to take it, a lot more took it.
It does satisfy the 9 elective credits that you have to take for the physics major. It will
It's
count.
Right, but it's one of a list.
Yeah, it's
Yeah.
one of the lists.
Okay.
So it does
It's an
fulfill a major
elective.
requirement, just
Okay.
not.
Yeah.
It's not a requirement.
Not a requirement.
Along with
Yeah.
history and philosophy.
Okay. Thanks for the clarification.
Yeah, I'm actually curious. Are there, like, do you have a sense of how physics majors perceive the class and why? Like, do you have a sense why it's not very effective?
I don't know. I didn't myself take it, but I know a lot of people who did, and specifically people who were interested in optics. Almost anybody who had any interest in optics took this course. But other than that, it was mostly an elective. People who liked the lab classes or had specific interest in optics were really the only ones who took it. Everybody else, because it doesn't fulfill the requirement, the research requirement, I think, got research from, like myself, from one of the faculty.
So there's sort of the common knowledge of undergraduates is that junior lab is a bear. It's like a lot of work for 2 credits. Does this class have that same reputation amongst the undergrads? Do they
so.
see it as
Yes.
somehow either
Yeah.
lighter or more fun or different?
If they don't, they should. All lab courses are more work than you expect.
Is this
a
also
full
2 credits?
This is a full 3 credits.
This is 3 credits. Finally.
Yeah. I don't know that they consider it any more of a bear than junior lab, but it's a lab, and they see it as a lab, and as usual with all the physics lab courses, they take more time than you get credit for. So I'm sure that is a factor in people avoiding it.
Yeah. So I guess we would be interested in like survey the undergrad population, just figure out like why they do or don't. Yeah, take it. So, thanks for that. So one of the motives for doing the reform project is to eliminate cookbook style labs. And basically, also just took this almost verbatim out of the grant. We define cookbook as just a list of a variety of specific activities and measurements to be completed to arrive at a desired answer. So just like step 1, step 2, step 3. So the example here is just copied from week 1 lab. So there's one lab that all the students take at the same time. That is the week 1 lab, and it's on the projection microscope. Equipment just uses like basic optics bench and some lenses and stuff. And so we have enough equipment for all the students to do it at the same time. And so this is what they see. This is the outline of the experiment. I mean, you want to, you can take a couple minutes or not minutes, but seconds to look at it. But it just tells you step by step what you need to do and what you need to measure. And then eventually you just write down some numbers.
But how do students learn? Oh, they click on line spacing?
This is copied from a PDF. Like they're in lab, they get this as a PDF file. This is their handout for their instructions, and they set up this stuff. I mean, I stripped away some of the introductory material.
Okay, so I mean, part of it is because while it is cookbook in style, there are lots of things that students have to know. So, for instance, under 2 bullet 1. All right, use the grading formula, but that doesn't tell you operationally how to use the grading formula to look at the diffraction pattern on the wall or measure the distance or, right? Mm-hmm. How do you get theta n, right? Mm-hmm. So, is that provided, or do students come up with different, because there are many different ways of doing that too?
No.
Yep.
How do you get theta n?
What?
Just ask.
Right.
I'll go from Carol to Carol
say.
answering the exact same question. That's what really happens.
Right. Okay. Right.
So that's what one of the experiments looks like. So one of the slogans kind of this reform is this quote by Lord Kelvin: "To measure is to know."
Such an experimentalist, dude.
Yeah, it's great. Well, physics is an experimental scientist. Most physicists are experimentalists. There's a ton more chemists than there are physicists, maybe by like a factor of 4, and they're like even more dominated by experiment. So it seems like the fact that to measure is to know. Like the course should sort of reflect the way physicists get knowledge. But it could have been that Lord Kelvin was actually a proponent of cookbook style labs, and he knew if his students just measured that one quantity that they were just told to do, that they would understand it. Or it could be that he has this bigger picture of how scientific truth comes about through experimentation. But probably the latter. Yeah. So are we achieving success? No, it seems, and that's actually why Heather, from talking to Heather, why she was really motivated to change things. That's why Chuck, who's not really into PER so much, he just wants to make the class better for his students. And he sees when they're frustrated and when stuff just doesn't work. He wants to change. So a lot of these labs have been around for 20 years, but we hope to change things. So I just wanted to briefly mention a few alternatives to the dull cookbook labs. So back in 1997, the American Association of Physics Teachers put out kind of a well thought out statement about what the introductory physics lab should look like. And they had like all these different key areas which are listed up here. But it kind of gave you like a big picture of what is the purpose of a lab class. And I highlighted this part at the bottom because I said many of these goals are not explicit in traditional laboratory programs. And it seems to be that's probably the exact same situation Advanced Lab is in now. There are these kind of big picture, like goals we have for lab class, but just in terms of like being explicit about meeting them, it's just not there. In fact, can I say anything else about this? Yeah. So in fact, like there is an Advanced Lab Committee of AAPT, and they issued a statement about like progress towards making advanced labs better. But they actually said we're not going to say anything about goals right now, or content or anything, just because that's too thorny or too tricky. So they actually backed away from even producing something like this for the advanced lab, and just said, well, we need to do more networking. We need to do like conferences that get people more involved and raise awareness within APS and stuff like that. So yeah, but it seems like it is in the works for advanced lab too. So actually implemented at the introductory level, it seems like Rutgers, the group of Eugenia Etkina, has a lot of stuff. They produce some good research where they've implemented a kind of a more inquiry-based or design-based lab, intro lab course. And also they've done the education research on it to see how effective it is, and they've compared it with non-design, more traditional labs. And so this is just acting like a physicist, student-approached study to experimental design. So they specifically wanted to look at some of these things, like how do you design an experiment? How do you teach people to design an experiment? What do they do when they kind of get stuck when trying to solve a problem? Do they just immediately ask the TA, or do they figure it out, discuss things, and figure it out on their own? So like I think like they offer one like pretty good model. They did it at an introductory level, but there's probably a lot that could be adapted towards a more advanced level. From the advanced lab community within AAPT and across a lot of different colleges and universities, there is a big push to make exciting labs. Just like good, high-quality labs. And I copied this from the Alpha website, the Advanced Laboratory Physics Association. And basically it's just a bunch of different advanced lab instructors. Some people, that's their dedicated job. Some people are professors who teach it once in a while. But it's a whole bunch of, but basically what they're trying to do is just kind of distribute the best materials that are out there. And so they've started these immersion courses, and I have some of them listed from last summer. But they're just kind of advanced lab topics that are just done in a good way. Yeah, so they're good materials, they're interesting, they probably work well, unlike some of the experiments that are currently in the advanced lab now. But like they're not part of this like bigger picture of like saying what is the goals of the advanced lab and how do we assess it? That part of the picture is not really in the community yet. So what we're going to try to do is create some synergy between what Alpha is doing in terms of trying to make really good labs. Take the existing PER reform model from that cool circle diagram, and then take some of the existing literature about what's been done at the undergraduate, the intro undergraduate level, and just put that all together. Those are the big sources we're going to draw on in this project. So this is wild conjecture, unsubstantiated opinions. But this is like
that's what we specialize in.
This is actually kind of why I'm excited about this lab. So I called it critical thinking gone amok because when I look back at my undergraduate lab experience, error analysis was always one of like the things that was like hammering. You got to do error analysis, right? But that only takes place like after you've taken a bunch of data, right? And it is an essential part of like making a good scientific argument to understand where your errors are and how they got there. But it's just one part of the big picture of like critical thinking and sense making. So at least in my opinion, there's this big picture of what it means to like do an experiment, and a lot of that is actually applicable across many different disciplines. In fact, in the Rutgers group, they were training their students to do an introductory physics lab, and then they would give them a bio lab just to see how they transferred their stuff about experimental design stuff, how they transferred that to just an unfamiliar content. And it seems like they do a good job because science is science. That's why it's one group of things. But error analysis is really particular to the quantitative sciences, like physics. So it's very essential to us to know it. But it's just one particular thing. So why is there so much error analysis and so much less talk about the other aspects of doing an experiment?